At just 6 months into the year, SpaceX's 45 rocket launches have set a new world record for the highest number of successful launches in the aerospace industry. The undisputed title belongs to the Falcon family, accounting for 44 of the total launches. The key to this resounding success lies in the remarkable engineering prowess of Merlin engines, which power the Falcon 9 rocket. These highly innovative rocket engines marked a massive milestone, not only securing SpaceX's leading position, but also breaking Russia's monopoly on launching payloads to the ISS. So what is it about the Merlin engine that makes it so special? And how can the Merlin engine kick Russia out of their exclusive launches to the ISS? Stay tuned as we dive into these topics and more in this episode of Alpha Tech. Amidst the ongoing discussion surrounding the Starship's Raptor engine, we may have overlooked the importance of the Falcon 9's engine, the Merlin engine, which laid the foundation for SpaceX's development. Even today, because of this ingenuity and attention to detail, thanks to SpaceX's skilled engineer, it remains an amazing piece of engineering brilliance. The Merlin engine is a gas generator cycle engine that runs on RP-1 and was primarily developed by SpaceX engineer Tom Mueller, one of the early employees of the company. Thanks to SpaceX's continuous development approach, the Merlin engine currently holds the title for the highest thrust-to-weight ratio among operational engines. With a thrust-to-weight ratio of 184, the Merlin engine even surpasses the Raptor 2 engine in terms of thrust-to-weight ratio, which is 144. This is a nice touch that sets the Merlin engine apart. When the thrust-to-weight ratio is high, you might think that the weight added by the higher thrust of the engine would be relatively small compared to the fully fueled second-stage rocket it propels. But for the first-stage rocket landing of the rocket in the unique way that SpaceX did, the high thrust-to-weight ratio helps reduce the amount of propellant needed for landing, and that propellant weight adds up significantly. Recently, SpaceX has employed a unique technique for the vacuum Merlin engine used in the upper stage of the Falcon 9 rocket. The engine used in their rockets now features a noticeable absence. A significant portion of the nozzle is missing. In traditional rocket engines, the nozzle plays a crucial role in optimizing thrust and propulsion efficiency. The complete nozzle design ensures that the exhaust gases are directed in a precise and controlled manner, maximizing the engine's performance. However, by choosing to omit a substantial part of the nozzle, SpaceX has opted for a configuration that deviates from conventional wisdom. While this design may seem counterintuitive, as it sacrifices efficiency, SpaceX remains undeterred. They've meticulously developed and fine-tuned a working method that consistently yields successful outcomes. SpaceX announced on Twitter that a shorter second-stage nozzle will be used when we don't need as much performance to get the payload to its final destination. By saving the nozzle portion of the engine, SpaceX can achieve some benefits. First, SpaceX can significantly reduce production timelines, enabling them to deliver their rockets to the launch pad faster. This time advantage can be crucial in meeting tight mission schedules and ensuring timely deployments of satellites or other payloads. In addition to time savings, reducing the weight of the engine plays a pivotal role in optimizing the overall rocket performance. This enhanced payload capacity can enable the launch of larger satellites or facilitate the inclusion of supplementary equipment, expanding the capabilities of each mission. Finally, SpaceX can reduce production costs, making their launches more financially viable. This cost efficiency is crucial in the context of the increasingly competitive space industry, where companies strive to offer affordable and accessible launch services. Besides, SpaceX still uses the full-size Merlin vac nozzles on missions that require a more significant amount of thrust or contain a heavier payload. Another notable aspect that cannot be overlooked is the impressive power of the Merlin 1D engine. It's capable of producing over 1.7 million pounds of thrust upon liftoff. Equipped with 9 of these engines, the 229-foot-tall Falcon 9 rocket stands as the most powerful single-core vehicle in the American fleet. The second stage of the Falcon 9 is driven by a single Merlin engine, which can carry an impressive payload of 25 tons to low Earth orbit. In recent years, advancements have led to the development of the Merlin 1D vacuum engines, with an astounding pushing capacity of 80 tons and a specific impulse of 282 seconds after several years of use. The design features of the Merlin engines further showcase their engineering excellence. The Merlin engines utilize a dependable turbopump design featuring a single shaft that drives the liquid oxygen pump, fuel pump, and turbine. It rotates at a speed of 36,000 revolutions per minute and generates 10,000 horsepower or 7,500 kilowatts to power the engine. Unlike the more complex staged combustion cycle used by some engines, the Merlin engine utilizes a gas generator cycle, streamlining the overall design and increasing operational efficiency. Additionally, the regeneratively cooled thruster chamber features a milled copper alloy liner that provides ample heat flux margins, enhancing performance and durability. One notable design feature of the Merlin engine is the pintle injector, which ensures inherent combustion stability. This injector, originally used in the Apollo lunar module landing engine, enables precise control of the propellant flow and contributes to the engine's overall reliability and performance. These design choices reflect SpaceX's commitment to engineering innovation and optimization, resulting in an engine that pushes the boundaries of what's achievable in space travel. The pride in the Merlin engines doesn't stop there. In addition to their technical strengths, one of the key highlights of the Merlin engine is undoubtedly their reusability and reliability. According to data from daily astronaut reports, these engines boast an impressive reliability rate of 99.9%. The Merlin engine has undergone extensive testing, including multiple static fire tests and numerous successful launches. It has also been designed with redundancy and fault tolerance in mind to enhance its reliability. SpaceX has consistently strived to enhance the engine's performance and resolve any identified sources by implementing iterative design changes and rigorous testing. Essentially, SpaceX has utilized a proven and relatively simple rocket design and optimized it through modern materials and advanced manufacturing techniques. Furthermore, the Merlin engine's reusability plays a role in its reliability. They can be reused for approximately 10 flights, making them incredibly cost-effective and efficient for SpaceX's mission objectives. SpaceX opted for the size of the Merlin engine for production reasons. Instead of manufacturing one or a few large engines using traditional manual methods, they employed a rational assembly line and modern processes. This approach allows them to produce their engines at a significantly lower cost with fewer stability issues. If you're a fan of SpaceX, you probably noticed the consistent approach of choosing to manufacture and integrate multiple smaller rocket engines instead of fewer larger ones, which was previously done with the Falcon 9 and its Merlin engines. The reason for this, Elon once explained, it's sort of like the way modern computer systems are set up, Musk said. With Google or Amazon, they have large numbers of small computers, such that if one of the computers goes down, it doesn't really affect your use of Google or Amazon. That's different from the old model of the mainframe approach, when you have one big mainframe, and if it goes down, the whole system goes down. And in the end, it's better to use a large number of small engines, Musk said. It was Elon's unwavering determination and courage to face failure that made the difference. At the time, the unique Merlin engine coexisted with the Falcon 9 rocket and achieved important accomplishments. What's more remarkable is that it delivered an unforgettable blow to the Russian aerospace industry. In early 2022, Russia's state space corporation's Roscosmos issued its round of threats in response to global sanctions, that this time claiming Russia would no longer sell rocket engines to the U.S. The former administrator of Roscosmos, Dmitry Rogozin, announced the new policy in an interview with a Russian channel. Today, we have made the decision to halt the deliveries of rocket engines produced by NPO Energomash to the United States. Let me remind you that these deliveries had been quite intensive somewhere since the mid-1990s. Rogozin also added, "Let them fly on something else, their broomsticks, I don't know what." It was indeed regrettable for the former head of Roscosmos. This seemed a very serious problem for the U.S. space industry, but Rogozin may have forgotten about the existence of the SpaceX Merlin engine. At that point, In response to Rogozhin's mockery when calling U.S. rockets broomsticks, Elon Musk shared a video of SpaceX launching 47 Starlink satellites on a Falcon 9 at Kennedy Space Center in Florida. Unsurprisingly, Rogozhin's mouth was shut by this. More than that, the Falcon 9 remains tirelessly engaged as the primary rocket responsible for crucial missions within the U.S., including the transportation of cargo and crew to the International Space Station. The combination of Merlin engines and the Falcon 9 has exerted dominance without encountering the slightest risk of uncertainty. In fact, one could consider it a golden opportunity, a testament to the remarkable capabilities and unwavering reliability that the Merlin engines bring to the table. With their exceptional performance and unmatched track record, they've solidified their positions as the backbone of SpaceX's ambitious space exploration endeavors, paving the way for future achievements and opening doors to boundless possibilities in the cosmos. Elon Musk is going to take us to Mars with this amazing space engine. Hidden away in a Texan hangar is a brand new rocket engine that'll put us on Mars, help us explore the moon, and even further dominate the aviation industry. So, how awesome is this engine? The SpaceX Raptor is a cryogenic stage combustion rocket engine intended to power the high-performance lower and upper stages of the Mars-bound rocket Starship. It has more than 3 times the thrust of SpaceX's Merlin 1D engines, propelling the Falcon 9 and Falcon Heavy rockets, and steps away from a kerosene-based propellant. Raptor consumes a combination of liquid methane and liquid oxygen in a full-flow stage combustion cycle. And because it's so hard to develop, no engine like this has ever flown before. The highly reusable engine makes use of concepts that were first shown to us on the Falcon 9 and Falcon Heavy rockets, including deep cryogenics that are cooled below their boiling point to increase their density and then load the limited tank volume with a bigger mass of propellant. Like SpaceX's Merlin engines, at least 2 versions of the Raptor will be available. One for use on the first stage booster of the Starship launch vehicle, and the other for use in vacuum for operation outside the Earth's atmosphere for the interplanetary insertion and in the ambient Martian atmosphere for retro-propulsion prior to landing. Raptor's design was revealed back in 2016 during an address given by Elon at the International Aeronautical Congress, where he broke down SpaceX's Mars transport architecture. Known as the first version of the Raptor family, Raptor 1 is one of the cleanest burning rockets on the market. Sadly, while Raptor 1's been refined over the years, it's now an obsolete design. Its construction is complex, tough to manufacture, and has a long turnaround between launches. It also has hit a thrust ceiling of 185 tons, meaning it's going to struggle to reach Musk's demands for a Mars-bound Starship. SpaceX's solution then was the Raptor 2, which has a large number of performance and reliability upgrades. However, Musk's primary goal is for the cost per ton of the thrust of Raptor to be under $1,000. This means Raptor needs to be $250,000 to produce. Hence, Raptor 3 was born. And during the unique Raptor 3 engine test, SpaceX treated the rocket science community to a breathtaking spectacle. Test footage revealed the awesome power and fiery brilliance of the engine as it roared to life, leaving onlookers in absolute awe of its might. It signifies a remarkable advancement in performance and propels the boundaries of what's possible in space exploration. Tested under rigorous conditions, the Raptor 3 engine astounded experts with exceptional capabilities. Amidst the excitement, Elon Musk, the visionary behind SpaceX, took to Twitter to share the remarkable achievements of the Raptor 3 engine. It's really generating a staggering thrust force of approximately 269 tons and operating at a chamber pressure of 350 bar. By comparison, the closest engine to Raptor that uses a phased combustion cycle with methane and oxygen is the BE-4 engine, which is expected to produce about 245 tons of thrust. This special version 3 surpasses the popular rocket engines such as RS-25 with 190 tons and RD-180 with their 2 combustion chambers. And the Raptor 3 engine outperforms its predecessor, the Raptor 2 engine, with numbers as impressive as up to 18%. This substantial increase in performance is a testament to SpaceX's relentless pursuit of innovation and their commitment to pushing the limits of rocket technology. Wow, 350 bar is a record-breaking number. It's now defeated all the most powerful rocket engines. It's surprising because the previously thought chamber pressure belonged to the F1 engine that propelled the iconic Saturn V rockets during the historic moon missions, operating at a mere 70 bar. The RD-180 engine used in the Atlas V rocket has a respectable chamber pressure of 267 bar. Moving forward on the timeline, we encounter the RS-25 engine, the mainstay of NASA's Space Shuttle program, which only reached 206 bar. In the world of rocket science, where every ounce of thrust matters, the chamber pressure is the basis for creating the powerful thrusts of the engine. Raptor 3 chamber wall might have the highest heat flux of anything ever made, Musk tweeted. As the pressure within the combustion chamber rises, the propellants experience a more forceful expulsion, resulting in a greater velocity as they are propelled through the engine's nozzle. We remember, according to Newton's third law of motion, this forceful expulsion creates an equal and opposite reaction, providing the necessary thrust to propel the rocket forward. This enhanced thrust enables rockets to carry heavier payloads, achieve higher velocities, and the grand goal, to ultimately be able to go on more ambitious space missions. A higher chamber pressure leads to a greater thrust output, enabling a higher thrust-to-weight ratio. This ratio is crucial as it signifies the amount of force the engine can produce in relation to its own weight. A higher thrust-to-weight ratio empowers the rocket to carry heavier payloads or achieve enhanced acceleration, which then ups the range of missions it can go on. On top of that, the importance of chamber pressure extends to the design flexibility of rocket engines. Higher pressure offers engineers the ability to achieve desired performance characteristics while maintaining compact and lightweight engine designs. This flexibility is crucial as it allows the development of advanced launch vehicles that can go on various mission requirements, including crewed missions, deep space exploration, and satellite deployments. The Raptor engine's efficiency makes it the granddaddy of all the other rocket engines out there. We can't say for certain that this will be the final version of the Raptor, nor can we confirm that it'll be used on the second Starship test launch, but anything's possible, because SpaceX's limits are limitless. Here's to hoping we see the Raptor 3 reveal themselves at Starbase soon. To attain these goals, the Raptor engine has undergone a ton of ongoing improvements and iterations, showcasing the company's commitment to pushing the boundaries of rocket engine tech. Raptor 3 represents a significant step forward in engine development and boasts major advancements in performance, efficiency, and overall capability. With the Raptor 3, SpaceX aims to achieve even higher thrust and reliability, pushing the limits of what's possible in rocket propulsion. There's bound to be a lot of speculation about the future of Raptor engine iterations, especially whether Raptor 3 is a temporary replacement for Raptor 2, nor do we have much information on SpaceX's long-term plans. But we can safely assume that Raptor 3 most likely serves as a transitional phase, allowing SpaceX to gather valuable data and insights while simultaneously working on further refinements of the engine. Don't forget, SpaceX has always had a very unique approach to the development of engines or rockets compared to others out there. They're always focused on rapid iteration and ultimately upping their game. So it's not uncommon for the company to introduce intermediate versions of their engines before reaching a final optimized design. This iterative process allows SpaceX to test new concepts, identify areas for enhancement, and refine their engines to achieve optimal performance. However, the path to innovation is not without its challenges. The development of the Raptor engine has not been without occasional setbacks and engine failures. SpaceX acknowledges the engine testing is a complex and demanding process, and sometimes engines may fail during testing, either unintentionally or on purpose. It's clear that Raptor is currently in its infancy. Similar to what SpaceX did with the Merlin, the engine will continue to evolve as SpaceX flies more, builds more, and tests more. Nevertheless, despite this challenge, SpaceX is staying the course in their commitment to advancing the Raptor engine. The company understands that these setbacks are all a necessary part of the journey towards creating a more efficient and high-thrust engine. One of the greatest human endeavors ever undertaken is the exploration of space. A big part of the surprise is the complexity. There are so many problems to solve and so many obstacles to overcome. But the most significant challenge is harnessing enough energy from rocket engines to propel a spacecraft in a zero-gravity environment. Thankfully, SpaceX has done this, and they've done it well. They built a crazy Raptor bigger and better. But how does it work? And how could this change everything? The Raptor vacuum engine is basically a space version of the Raptor engines that'll lift off from Earth underneath the Super Heavy booster. The variant of the Raptor engine will help the Starship travel through the vacuum of space by generating higher specific impulses inside the vacuum. It's like a steering wheel that's responsible for letting the spaceship in space move smoothly. Previously, the Starship was constructed with only 3 Raptor vacuum engines and 3 sea-level Raptors. However, with the latest revelation by Elon on social media in July, 3 more engines for the meaning of life, we will have a total of 6 Raptor vacuum engines powering SpaceX's spacecraft. The generated thrust will be formidable enough to execute the upward force required to lift the Starship while overcoming Earth's deep gravitational pull. Evidently, it stands apart from the smaller sea-level variants tested thus far. This iteration of the Raptor engines operates at an entirely different level in terms of both altitude and power. Have a look at this previously released photo of SpaceX. The Raptor vacuum is gargantuan. This enhanced size is primarily attributed to the significant expansion of the engine's nozzle. The widened nozzle of Raptor vac engines result in an area ratio of 200, necessitating a nozzle diameter of approximately 4 meters. This enlargement of the nozzle positively impacts operational efficiency within the vacuum of space. Due to its characteristics in a vacuum environment, the Raptor vacuum engine boasts an impressive thrust of 357 tons, with a specific impulse reaching a remarkable 380s. The specific impulse measurement surpasses that of many renowned rocket engines, including the vacuum version of the BE-4 engine with a specific impulse of 339s, the RD-180 with a specific impulse of 338s in a vacuum, and even the legendary RS-25 Space Shuttle engine with a specific impulse of 452s, but featuring 2 combustion chambers. But why do we compare specific impulses between vacuum engines? Specific impulse signifies how efficiently a rocket expels its propellant. It quantifies the rate of thrust generated by expelling propellant from the nozzle and is measured in seconds. A higher specific pulse implies a greater expulsion velocity of the propellant. This metric serves as a measure of engine quality, essentially reflecting how quickly the engine burns fuel to propel the rocket upwards. This is the most crucial key performance indicator of a rocket engine, as a faster and more efficient burn rate can accelerate the rocket to higher altitudes and velocities with less fuel consumption. Additionally, the specific impulse for vacuum engines always exceeds that of sea-level engines. In a vacuum, there's no atmosphere to provide pushback against the expelled gas, unlike at sea level, where the ambient atmosphere contributes to the thrust. For instance, SpaceX's current Falcon 9 launches employ the Merlin engine, which exhibits a specific impulse of 282s at sea level and approximately 311s in a vacuum environment. Therefore, it's only natural for the Raptor vacuum to possess greater power compared to its sea-level counterparts. Honestly, the future iterations of the Raptor vacuum engine are likely to be even more potent, possibly up to 400s, an impressive figure among all rocket engine lines. This is because SpaceX's engine development is progressing at an exceptional pace, exemplified by the Raptor 3 version, which boasts a staggering 17% increase in power compared to the current Raptor 2. We can't wait to see this. It's going to be awesome. Not only outperforming other rocket engines, but the Raptor vacuum engine is also a significant milestone in SpaceX's pursuit of advanced propulsion technology. This innovative vacuum engine variant builds on the foundation of its predecessors, incorporating distinctive features that cater to the demands of space travel. At the heart of the RapVac prototype is its ingenious regenerative cooling system. Unlike conventional cooling methods, regenerative cooling involves circulating propellant, such as methane, through the walls of the engine's nozzle and combustion chamber. This process effectively absorbs the extreme heat generated during combustion, and it prevents overheating and structural damage. The regenerative cooling system enhances the engine's endurance and longevity, enabling it to withstand the rigorous conditions of space travel. The manufacturing process of RapVac's nozzle is equally remarkable. Crafting regeneratively cooled nozzles traditionally involve labor-intensive methods, such as assembling thousands of individual pipes. But the RapVac engine takes a novel approach. The nozzle is meticulously crafted from a copper sheet. This copper sheet is then enveloped by Inconel sheets. creating a sturdy and efficient channel wall. This manufacturing technique streamlines the production process and contributes to the engine's overall efficiency. In its pursuit of optimal performance and durability, the RapVac engine boasts additional reinforcements and protective elements. These components are strategically incorporated to enhance the engine's structural integrity and mitigate potential challenges. Notably, the interior of the engine features a white ceramic material, believed to reflect heat and safeguard the chamber wall against oxidation. Additionally, the design of vacuum engines is also given careful consideration to maximize their efficiency. The first factor that needs attention is the expansion ratio, which holds paramount importance in vacuum engines. This ratio, which represents the ratio of cross-sectional area of the engine's exhaust nodule at the throat of the area of the exit, plays a pivotal role in determining the engine's overall performance. A higher expansion ratio leads to enhanced efficiency by enabling the engine to extract more energy from the expanding exhaust gases as they propel the spacecraft forward. However, as engines venture into the realm of larger nozzles, a complex challenge arises in the flow separation phenomenon. Flow separation occurs when the pressure of the exhaust gases drops significantly, leading to the atmosphere exerting pressure back into the nozzle. This phenomenon can result in adverse effects on engine stability and thrust efficiency. Large nozzles are particularly susceptible to flow separation due to the decreased pressure of the exhaust gases in the vacuum of space. Here's a video that shows the main engine of the space shuttle running at full power. Before reaching the maximum thrust, you can see the exhaust flow spreading around the nozzle's tip, then gradually increasing, similar to accelerating a vehicle. Additionally, you can observe the nozzle oscillating more as this phenomenon becomes more pronounced in the rear. This phenomenon generates significant lateral forces, which, if sustained, could potentially damage the engine. Addressing the challenges posed by flow separation in large nozzles is vital for optimizing engine efficiency and stability. Engineers must carefully balance expansion ratios and nozzle sizes to mitigate the adverse effects of flow separation. Through meticulous design and advanced simulations, they strive to achieve a harmonious flow of exhaust gases that maximizes thrust while minimizing flow separation. Besides, the quest for an optimized RapVac engine also entails adjustments beyond the nozzle. The engine's powerhead, the heart of its intricate machinery, might need re-engineering to accommodate changes in flow rates and pressures. Furthermore, the intricate dance between propellant pumps and a dual turbo pump configuration demands meticulous synchronization to ensure optimal thrust production without compromising combustion efficiency. These changes, while challenging, could unlock the engine's full potential and set new benchmarks for space propulsion. In general, SpaceX's Raptor vacuum is a mysterious beast in space. And as Elon keeps tweaking and upgrading those Raptors, the Raptor vacuum will also benefit from his genius. But we haven't seen it in action yet. Starship 25 is still waiting for its date with a Raptor vacuum. Maybe they'll hook up by the end of the summer if Elon keeps his word. And we can't wait to watch him soar into the sky and part ways gracefully. That's all for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comments section below. Your feedback's very important to us and helps us make better videos for you. Thank you so much for watching, and see you next time.